How many pairs of positive integers a, b are there such that a and b have no common factors greater than 1, and a over b plus 14b over 9a is an integer? The first thing I would like to do is let a over b equal x, and that will help us solve this problem. So that makes this equal to the following: x plus 14 over 9 times 1 over x. Now this is equal to some integer n. So I will transform this into what will be a quadratic equation. Multiplying through by x, I get x squared plus 14 over 9 is equal to n times x. Put everything on one side and multiply through by 9. We get 9x squared plus 14 minus 9nx is equal to 0. And therefore this is a quadratic equation. And in order to get the solutions, I'm going to have to use the quadratic formula. So x equals minus b, which is minus 9n, plus or minus the square root of b squared minus n squared, minus 4a, which is 9, times c, which is 14, all over 2a, which is 9. Now x simplified becomes 9n plus or minus 81 n squared minus 504, all under the square root sign, and that's over 18. Simplifying this a little bit further, this gives me 9n plus or minus. I can bring out a 9, and that gives me 3 once I bring it out of the square root, and that leaves me with just 9n squared minus 56, all under the square root sign, all over 18. And simplifying even further, this gives me just n over 2 plus or minus 9n squared minus 56 under the square root sign over 6. Now remember, this is equal to a over b, and a and b are integers. So since a and b are integers, this will be a rational number. A rational number, of course, is any number that can be represented in the form a over b. And the only way that can happen is if this is not a radical, right? That has to be a number. And in particular, what we mean is that 9n squared minus 56 under the square root sign must be a rational number. And the only way that's possible is if what is underneath or inside the square root is a perfect square. So 9n squared minus 56 has to be some perfect square. We'll call it m squared. And now we will use this information to try to figure out what is n. Bring m squared over to the other side and factor, and you'll get 3n, m and m, plus or minus, like that. And that is equal to 56. Now what we have to do, we have to make a table and try to figure out all the possible values of this. Now, we've got to understand that these two numbers, when multiplied together, have to be equal to 56, correct? So I'll put 3n plus m here and 3n minus m here. Now I've got possible choices: 56 and 1, 28 and 2, 14 and 4, and 8 and 7. Now I can't put 7 and 8 here because 3n plus m has to be greater than 3n minus m. Right? It's got to be greater. So this is not going to be needed. We just have to work with these 4. So let's do that. Let's work with those 4 and let's see what solutions we get. So for the first one, 3n plus m is equal to 56, and 3n minus m is equal to 1. Adding these, you get 6n is equal to 57, and therefore n is equal to 9.5. Now n, remember, has to be an integer, so this is no good. This does not give me any solutions. Next one, 3n plus m is equal to 28, and 3n minus m is equal to 2. Adding these, we get 6n is equal to 30, and therefore n is equal to 5. So this is definitely one of the solutions we are going to use to try to figure out a and b later. First, let's just complete this. In the next one, 3n plus m is equal to 14, and 3n minus m is equal to 4. Adding, you get 6n is equal to 18, and therefore is equal to 3. So that's another one that helps us. And then the last one, 3n plus m is equal to 8. 3n minus m is equal to 7. And this gives me 6n is equal to 15. And that would mean n is equal to 2.5, and that's not an integer. So 5 and 3 are my only values of n. So let's use those and figure out what we get for a over b using this equation right here. So for n equals 5, a over b becomes 5 over 2 plus this becomes 9 times 25 minus 56 all over the square root over 6, and this is plus or minus. So that gives me 5 over 2, 9 times 25 minus 56 is 169, and the square root of that is 13. So it's plus or minus 13 over 6. This gives me values of 28 over 6 and 2 over 6. And remember, we have to put this into lowest terms because a and b cannot have common factors greater than 1. So that becomes 14 over 3 and 1 over 3. So there we go. We've got ordered pairs, 2 of them. We've got 14 and 3, and we've got 1 and 3. Now let's do the exact same thing for n equals 3. A over b is therefore now going to be using this formula up here. 3 over 2 plus or minus 9 times 3 squared, which is 81. 81 minus 56 is 25, and the square root of that is 5. So 5 over 6. So this makes a over b equal to either 14 over 6 or 4 over 6. Okay? And of course we have to reduce that, so that's going to be 7 over 3 or 2 over 3 for a over b. And that means we got 2 more ordered pairs, and those are 7 and 3 and 2 and 3. So there you go. We got 1, 2, 3, 4 ordered pairs, and therefore